name is Anjana Jha and my student Coventry ID is 1482547. So today we are here for our assignment presentation through the outputs that has been done in our studio for the topic shopping mall sales data using polynomial regression, and we have implemented this using our studio. And whatever things are mentioned in an assignment that will be discussed in thoroughly through the R studio. So for that I have imported the necessary libraries that will needed for these assignments like matplotlib, ggplot, rsample, gamlet, vdata, and mass. So after importing the necessary libraries, we have that csv file that has been used as the resource file for this project, for this assignment. That the file has been provided through our school pro app, and the file has been imported, and I have read the file and it has given the data like this. So these are the necessary inputs that has been taken out from the file, and after getting the appropriate data, I have checked for the missing values in the data set. So I got to know there are no missing values, and after getting the information, so I have converted into the data frame. So data frame has been converted and it has been implemented as data frame. So now we are on generating the counts for ages. So we have generated the ages counts here and printed the results as like this. So you can see the results like 37 and its count number. So ages count has been generated like this, and similarly we have whatever inputs in the required in the values for customer data set. So input and output of customer shopping data. So inputs have been implemented in that way. So on next input is gender. So gender is implemented as male and female. Similarly, it's about categories. So these are the categories that will be used as inputs in our assignments, and for this we will be doing the predictions as well. So next is payment method. So payment methods are debit card, credit card, and cash. Similarly, the shopping malls data has been seen as the unique mall. So these are the shopping malls listed. So these all are the string values. So after we have to convert these values into numbers to get the actual data. So the data has been converted into the numeric values. So numeric has been converted as like using this function. So after converting all the values into numeric values, the output can be seen as like this. So these are the outputs that has been generated into the numerical form. So after generating into the numerical form, now the time starts for plotting the input and output data into the picture. So for that we have used the table as inputs and outputs. So we have, for this we have the categories and its cells, that will be price, that will be listed as price. So now we'll be seeing the picture for input and outputs in the customer sales data. So for this we will be plotting into the time series value. So to convert into time series value, this has been used as the function which has given us the values like this. So the time series of input has been generated, where we can see the inputs as age, category, price, payment methods into the invoice data as output. So this can be seen as a time series plot of inputs versus output. The clear picture has been seen as like this. So moving forward, we have this tax 1.1 that has been the customer time series plots. So overall the time series plot is seen in year and month. So this is like output that has been like sales data for the how much sales is performed year per month. So can clearly define the inputs and outputs like this in time series value. So after getting the time series, we come to next part, that is our task 2, that will be defining the density function and distribution for itself. So distribution for itself has been some steps to be followed. So like I have assumed the density of price like this way, and after getting the values of density of price, we have histogram and density of price like this, and after that like other values like payment and histogram and density plot for payment. Similarly for age, density and histogram, then histogram function. Similarly for category, we have density plot and histogram plot as well. Similarly we also have the inputs, we have the input quantity. So for quantity we have density plot and histogram plot, and all the inputs have been plotted in this way. And after plotting inputs and output to get the proper correlation, it can be seen as like the values will be seen as like this, so that proper correlation has been obtained after the histogram and density plots, and the values are generated like this. And when we see it in graphs, so this can be seen as like this correlation between age and quantity signals, and correlation between price and density. That has been some like data has some far from 2 points, and like this has a random which has a similar pattern of data. And similarly category and quantity, and payment method and density. So these are the correlation between the inputs and outputs, different inputs versus the proper output as quantity. So after seeing the data for time series plots, the task 1 has been finished in this way. After getting the correlation and scattered plots, so we can find the scattered plots and correlation for all the datas. And after getting the datas, we can see at it on a glance of like input versus output, age, category, price, payment method and quantity. It's on a glance. So let's move to task 2. So task 2 has regression modeling using relationship sales data. So to calculate regression, we have been given some equations for model 1, 2, 3, 4, and we have to calculate theta hat model for the same. And for these two tasks 2.1 and 2, 3, similarly we have to calculate the values, RSS values, likelihood function, and AIC and PIC. So let's move for task 2. So for task 2 we have certain equations for that. So I will be taking the inputs and putting into static variables. So after putting into variables, let's create the data frame and matrix. So after converting it into the matrix form, I have used the function lambda and alpha. So we can go through the equations for maintaining the equations. We have used alpha and lambda. So the equations for y1, 2, 3, which I have assigned to the outputs. So the output will be like the equations like we have model 1, 2, 3, 4, and whatever equations we have given we'll be implementing in that way. So for equation 1, this will be as column binding function has been used like this in the matrix form. So theta hat model 1 has been implemented in this way with following equations, and the result is like this. For similarly for equation 2, the column bind function theta model 2, theta model 3. So this is like the function. Similarly for output 4, column bind function equations 4, and theta is obtained like this. Similarly for equation 5, yes, after equation 5 we have obtained the matrix form of theta hat model. So we have, after obtaining the theta hat model, we have to calculate the RSS values. For calculating the RSS value, we have to go through the RIS module. So I have implemented the RIS module throughout the tax 2.2 and have printed the RSS value through the formula. So after implementing, we get the values like this, and for this is for our equation y1. So similarly, we have been implemented for all the 5 equations, and for the values I have implemented in the same way. For y2, we have implemented the values and it has been obtained as like this. Similarly for y3, it's like obtained like this, and y4 and y5 similarly. So output has been obtained like this way. So after getting the RSS values, we will be now calculating the likelihood function for the same. So we will be using likelihood functions with the formula that will be used as like this. So I will be implementing formula like this for all the variables and all the modules. So all the modules will be implemented like this, and finally I will be printing the variance values for all the modules. So let's see the values, like how it appears low. So it goes like this for module 1, 2, 3, 4. The likelihood values has been implemented in this way. So yes, after getting the likelihood values, we will be predicting module 1, 2, 3. So after final likelihood will be implemented in the data frames, and the data frames values will be final output is seen like this. So we finally obtain the final output of likelihood function. Now it's time for AIC and BIC for the same module 1. So for calculating AIC and BIC, we have the function like this. So I have implemented the formula for calculating AIC and BIC. So for all the modules 1, 2, 3, 4, the AIC and BIC is implemented and the output is printed in the same way at the end. So we are getting the values of all the modules initially, and that is converted into the AIC frame. So we are printing the AIC values at the end. So these are all the AIC values. So AIC will be printed in this way, while the BIC is implemented in the similar way, and we have obtained the BIC values. And in the same way, we have obtained the QQ plot model, and we have final the QQ plot for all the 5 modules. So we can view all the modules output, like QQ model for QQ plot for module 1, 2, 3 and 4 and 5 in the same way. After getting all the values, we will be now moving forward after dividing into testing and training values. So I have been divided the testing and training data into 17 and 1000%. So it has been seen as splitting values. So after splitting into the training and testing data, so we have finally implemented the confidence interval between the values. So confidence interval is calculated in that way. So after calculating the confidence interval, we have used the square root function for non-negative using AVS function. So AVS function has been implemented like this, and plotting has been done. So plotting has been done, and the plot can be seen as like this function that I have implemented. I've also checked the error bars for the same in confidence interval. So error bars are calculated like this, and legend has been focused like this way. So at the end, we have model prediction in 95% confidence interval, and training tested data models has been seen like this value. So overall training and tested data has been implemented in this way. So in this way, task 2 has been completed. For task 3, let's move to task 3. So for task 3, we have to find the theta bias module, and approximate Bayesian computation. So ABC method has been used for task 3. So let's move to task 3. So what we have done for task 3 is theta bias model has been implemented. For this, if else function has been used through our RSS model, and number iteration has been seen for performing our method ABC. So ABC method has been implemented in this way with all the plots all the plots has been seen and implemented in this way. So we have the values at the end is like the joint and marginal posterior distribution has been seen with input and output variables as like this. The function has been implemented like this, and for this the parameters are frequency and accepted values 1 and 2. So after putting the values into a single frame, we have obtained the output like this. So in this way the joint and marginal posterior distribution with ABC function has been implemented, and the results has been implemented in this way, and assignment is completed in this way. So thank you.